Reverse engineering. In this topic, we are going to cover reverse engineering and how it plays a vital role in the static analysis of Android APK files using various tools such as APK tool, JADX, Dex2Jar, and Ghidra. Reverse engineering is the process of examining an object, system, or technology to understand its inner workings, design, and functionality. This involves separating the object or system, analyzing its components, and studying its behavior and interactions. The goal of reverse engineering can vary depending on the context, but some common objectives include the following. Understanding how a product works to create a compatible or competitive product. Identifying and fixing flaws or vulnerabilities in a product's design or code. Recovering lost or damaged source code or design specifications. Creating documentation or instructions for a product that lacks clear documentation. Now let's understand reverse engineering for Android applications. Reverse engineering for Android applications refer to the process of analyzing the compiled code of an Android app to understand its structure, behavior, and functionality. There can be various reasons for the same, such as security testing. Reverse engineering can be used to identify vulnerabilities or weaknesses in an app's code, which can help developers improve the security of their application. App modification. Reverse engineering can modify an app's behavior or remove unwanted features such as ads or tracking. App cloning. Reverse engineering can create a copy of an existing app, which can be useful for developing alternative versions or creating counterfeit apps. Understanding how an application works. Reverse engineering can be used to gain insight into how an app works, which can be useful for app developers who want to create similar apps or for researchers who want to study the behavior of apps. Reverse engineering of Android application typically involves using specialized tools and techniques such as decompiles, dissemblers, and debuggers. However, it is essential to note that reverse engineering can be legally and ethically problematic without the consent of the application's developer or owner. Moving to our next topic, Android manifest.xml. The Android manifest.xml file is an important configuration file in Android applications that provides essential information about the app to the Android system. It is located in the root directory of an Android project and is required for all Android applications. The Android manifest.xml file contains metadata about the app, including the name, version, icon, and information about its components such as activities, services, and broadcast receivers. It also specifies the app's permissions required for accessing sensitive system resources like the camera, contacts, or location services. We will now look at some of the key elements of the Android manifest.xml file. Package name. The package attribute specifies the unique identifier for the app, distinguishing it from the other apps installed on the device. Activities. The activity element defines the user interface screens of the app, including their layout and behavior. Services. The service element defines background services that can run independently of the app's UI, such as media players or location tracking services. Broadcast receivers. The receiver element defines components that can respond to system-wide events such as incoming calls or low battery percentage. Permissions. The user's permission element specifies the permissions required by the app to access certain system resources such as the camera, contacts, or network. APK signature. APK signature is a digital signature applied to Android app packages to ensure authenticity and integrity. The APK signature is used to verify that an APK file was signed by the original developer and has not been tampered with or modified. APK signatures are based on public key cryptography and typically use the RSA or ECDSA algorithm. Creating an APK signature involves generating a private public key pair with the private key used to sign the APK and the publicly included in the APK signature file. When an Android device installs an app, it checks the APK signature to ensure that it is valid and matches the signature of the app's developer. If the APK signature is invalid or does not match, the Android device will prevent the app from being installed or run, as it may indicate that the app has been tampered with or is not trustworthy. APK signatures are an essential security measure in the Android ecosystem. It helps prevent the distribution of malicious or tampered apps and ensure that users can trust the app they download and install. The Android operating system requires all APKs to be signed before they can be installed on the device, and Google Play Store also requires developers to sign their apps with an APK signature before they can be uploaded to the store.